So imagine you break your arm, right? You go to the doctors, they take an x-ray, and there's this jagged white line.
Right. Very clear.
Exactly. The doctor points to it, and it's binary. You either have a fracture or you don't. It's clean, it's visible.
You trust your eyes?
Yeah. But today, I mean, that metaphorical x-ray machine is just fundamentally broken. We are looking at this diagnostic landscape where you literally can no longer trust the visual evidence of your own eyes.
It's a huge shift.
Really is. So welcome to today's deep dive. We're digging into a massive stack of testing data from the YouTube channel Futurepedia. And they basically crown a completely new king in the AI image generation space.
Which is saying something, given how fast this moves.
Oh, totally. Because for a long time, the reigning champion for, pure visual fidelity has been Nano Banana.
Along with its Pro and 2 variants, yeah.
Right. But according to this whole new battery of stress tests, Nano Banana has just been thoroughly dethroned by the newly launched GPT Image 2.0.
Which the source also refers to as ChatGPT Images 2.0.
Yes, exactly. Okay, let's unpack this because you might be listening thinking, great, another tool to make pictures of astronauts riding horses.
The classic example.
Right. But this isn't about novelty anymore. We are talking about these models crossing a massive threshold, like actual logical reasoning, flawless text generation, and deep autonomous research synthesis.
What's fascinating here is the underlying shift in how these networks actually operate.
How so?
Well, the transition from Nano Banana to GPT Image 2.0, it represents this monumental move away from what I would classify as aesthetic approximations.
Okay, aesthetic approximation.
Right, and moving toward genuine precision generation. Like, Nano Banana has always been exceptional at capturing the vibe of a prompt.
Yeah, the general feel.
Exactly. If you asked it for a schematic, it would give you something that, from 20 feet away looked like a technical schematic.
But if you zoom in, it's gibberish.
Totally. But GPT Image 2.0 is actually drafting the architectural blueprint. It's moving beyond just mapping pixels to mapping exact data, exact spelling, and strict spatial layouts.
Wow. And we're going to guide you through the specific, rigorous stress tests that Futurepedia used to really break the old models and prove the dominance of this new one.
It's a pretty intense battery of tests.
It really is. So let's start with the baseline visual upgrades. Initially, the source notes that attempts to get realistic images out of GPT Image 2.0 were, well, actually pretty underwhelming.
Oh, interesting.
Yeah, if you use the standard prompt language we've all been trained on for the past 2 years, phrases like realistic photo or iPhone photo or cinematic, the model just wasn't delivering.
Wow, right.
It lacked that sharp, lifelike quality. It looked a bit, I don't know, plastic.
Which, honestly, is incredibly common when a completely new model architecture drops.
Why is that?
Well, users try to port over their old prompt libraries, right? And then they get frustrated when the results actually degrade.
They just assume the model is worse.
Oh, exactly. When in reality, the latent space, which is the underlying multidimensional map where the AI associates text with visual concepts, that whole space has been completely rewired.
Right, the old keys don't fit the new locks.
Precise.
And then the creator had this massive breakthrough. They realized that by simply adding the exact two-word phrase, photorealism, to the prompt, the output completely transformed.
Just those 2 words.
Just those words. You could leave everything else in your paragraph-long prompt exactly the same. But just by slapping photorealism at the end, the image went from looking like a slightly stylized digital painting to a flawless, high-fidelity photograph.
That's a huge delta for one phrase.
It's crazy. And the source noted that basic prompt adherence across the board was stellar, even maintaining incredibly coherent faces in images featuring, like, massive crowds of people.
Now, the crowd coherence is actually a massive technical leap.
Really? Why is that so hard for them?
Well, in older diffusion models, you run into this severe issue with spatial attention. When an AI has to render 20 different faces in the background of a busy, crowded street scene, its attention mechanism gets diluted.
Like it loses focus.
Yeah, it starts losing track of where the structural boundaries of an eye or a jawline should be. And so the background faces start melting into these horrifying, abstract, fleshy shapes.
Oh, yeah. We've all seen the melty background faces.
Right. So the fact that GPT Image 2.0 maintains structural integrity across a crowd, it implies a much more robust cross-attention mechanism.
It's isolating those regions better.
Exactly. It's enforcing the structural rules of human anatomy, rather than just filling the space with flesh-tone statistical noise.
That makes total sense. But Honestly, the step-by-step editing is what really caught my eye here.
Oh, the sequence test.
Yes, the creator ran this incredible sequence to test how well the AI could hold on to a base concept while altering it dynamically.
Right, maintaining the subject.
So they started by generating an orc, just a standard fantasy orc. Then they prompted the AI to seamlessly give that specific orc a battle axe.
Handled it perfectly.
Yep. Next prompt, change the orc to a female orc. Then rotate the camera, zoom in, and add a red glow to the orc's horn.
That is a lot of localized changes.
It is. Now, the source did note a slight shift in the overall colors during this step, but they deemed it totally acceptable.
Fair enough.
And finally, they changed the angle to a perfect full-body front view. And throughout that entire sequence, the character consistency was just locked in.
Which is historically very difficult to pull off without external control meds.
Exactly. But I have to play devil's advocate here for a second.
Sure, go for it.
If this model is so incredibly advanced, why do we still need these magic keywords?
You mean like the photorealism tag?
Yeah. It feels like a secret password at a 1920s speakeasy, you know? You have to knock 3 times and whisper the exact phrase.
I see what you mean.
Like, if the model is smart enough to dynamically rotate a female orc 180 degrees and maintain her exact facial structure, shouldn't it inherently know what the phrase iPhone photo implies?
Well, I wouldn't call it a speakeasy password. It's really more like giving an actor a highly specific stage direction.
Okay, explain that.
You aren't unlocking a secret door. You're forcing the model's text encoder to isolate a completely different cluster of training data.
Ah, now see.
When the engineers trained GPT Image 2.0, that specific textual tag, photorealism, likely got heavily weighted toward a highly curated subset of unstylized, high-resolution photographic data.
So it points to the good stuff.
Exactly. The phrase iPhone photo, on the other hand, might be associated with a much messier data set.
Like what?
Images with digital noise, motion blur, poor lighting, or heavy compression artifacts.
So the model does know what an iPhone photo is.
Yes. And it's giving you exactly that, a slightly imperfect, processed digital image.
Okay, that makes sense. It's doing exactly what you ask, even if what you ask for isn't actually what you secretly want.
Precisely. Mastering AI isn't just about conceptualizing an image in your head anymore.
It's about speaking the language.
Yeah, learning the specific dialect of the tool you're currently using. You have to understand how its text encoder was trained.
And speaking of dialing in the tool, the source also tested combining 2 real photos into a single generated image.
Oh, this part was wild.
Yeah. So inside the standard consumer-facing chat interface, the face in the resulting image was a bit low fidelity.
Pretty typical for web interfaces.
Right. But when the creator pushed this exact same prompt through the API's 4K option, specifically testing it via a platform called Higgsfield, the facial clarity was stunning.
It was night and day.
Truly. And when they tried that exact same 4K API test with Nano Banana, the source noted it always looked, quote, pretty off.
And that distinction right there between the chat interface and the API, it is crucial for anyone trying to build professional workflows.
Why is the gap so big?
Because the interface you use to interact with these models often dictates the absolute ceiling of their capabilities.
Okay.
When you use a web-based chat window, you are frequently subjected to really aggressive image compression.
To save money.
Exactly. Strict parameter limits designed to save server compute costs. The underlying engine might be perfectly capable of 4K, poor-level facial clarity, but the chat interface compresses the output before it ever reaches your screen.
So it's throttling you.
Yeah. By routing the request through an API via a platform like Higgsfield, the creator totally bypassed those consumer guardrails,
Unleashing the full power.
allocating more processing steps and higher resolution outputs directly from the latent space. It's basically the difference between streaming a heavily compressed movie on a weak Wi-Fi connection versus playing it straight from a physical 4K disc.
That is a great way to think about it.
Yeah.
But getting a 4K face or making an orc hold a battle axe, while visually impressive, it isn't really the frontier of control anymore, is it?
Not at all.
Right. The real test isn't manipulating one digital object. The real test is managing complex spatial arrangements and, without a doubt, the most dangerous capability of AI imagery.
Human language.
Yes, human language. Which is a perfect pivot, because the second major area of testing was the text revolution. This is where we stop looking at pictures and start looking at pixels trying to communicate.
And this is exactly where the dethroning of Nano Banana truly solidifies.
Yeah, Nano Banana really struggles here.
Historically, AI image generators have treated text as a visual texture, rather than a symbolic language.
What does that mean, visual texture?
Well, if you asked an older model for a stop sign, it knew that a stop sign featured white shapes on a red hexagonal background.
Because it's seen a million of them.
Right. Statistically, those shapes always appeared together in the training data. But the model didn't possess the actual symbolic logic to know those shapes spelled S-T-O-P.
It was just drawing squiggles.
Exactly, white squiggles that approximated the visual rhythm of text.
Well, GPT Image 2.0 has apparently cracked that symbolic logic.
Completely.
The source showed an image of a whiteboard covered in complex math equations. We are talking dense, multi-line calculus.
Not just simple addition.
No, and every single character, every number, every mathematical symbol was structurally perfect.
That's mind-blowing.
Now, the creator did note that the handwriting was almost too nice-like, a bit too perfect for someone hastily writing on a whiteboard.
Sure.
And a few books in the background had some minor text issues on their spines, but the primary subject, the math itself, was flawless.
The jump from rendering a coherent human face to rendering a coherent multi-line mathematical equation is astronomical.
Why is math so much harder?
It means the model is no longer just predicting color gradients, it is predicting actual syntax.
Right.
To render an equation, the AI has to map the conceptual relationship of mathematical symbols to exact spatial coordinates on the digital canvas.
So it has to know what the math means.
In a structural sense, yes. Ensuring that an exponent actually floats in the correct physical proximity to its base number.
That is wild.
It requires an intersection of linguistic understanding and spatial geometry that older models simply lacked entirely.
And it gets even more precise. They generated a parody movie poster.
Oh, the billing block test.
Yes. We all know movie posters have that tiny, incredibly dense block of credit text crammed at the very bottom, right? The billing block.
Right.
The prompt asked the AI to generate specific text on there. It was, quote, music by Binary Bard, edited by Cut and code production designed by Pixel and Pine.
And it got it.
GPT Image 2.0 rendered that exact phrase, word for word, perfectly legible in that tiny, condensed movie poster font.
Unbelievable.
And when the creator ran that exact same prompt through Nano Banana, it warped the text into complete, unreadable gibberish.
Because Nano Banana is relying entirely on that aesthetic approximation we talked about earlier.
It just knows there should be text there.
Exactly. It understood the vibe of a movie poster. It knew, structurally, there should be a block of small white noise at the bottom of the frame.
But it couldn't actually write the words.
No, it didn't possess the precision to map your requested language into that specific visual noise.
Yeah.
It just gave you the texture of text.
Which brings us to the UI recreations. And honestly, this is the part of the testing data that gave me a bit of a chill.
It's the most consequential part.
The creator asked GPT Image 2.0 to generate a screenshot of the Midjourney website's Explore page.
An AI generating another AI's website.
Yeah, meta, right. But it was terrifyingly accurate. The layout, the image grids, the spacing. Then it generated realistic social media comment sections.
I saw that.
Every single profile picture was coherent. Every unique username was spelled correctly. The text of the comments read naturally. It looked flawless.
It's staggering.
But the ultimate test of this was generating a complex, comfy UI workflow screen.
Now, for listeners who might not be deep into the engineering side, Comfy UI is an advanced, node-based framework.
Very technical.
Yeah, it's where developers manipulate the raw tensor data and conditioning pipelines directly. It is an incredibly dense interface of interconnected parameters, values, and flow paths.
Exactly, and GPT Image 2.0 generated the screen complete with highly specific, accurate text inside the nodes.
Specific jargon.
Yes. It explicitly wrote out phrases like animate diff, negative prompts conditioning, motion LoRa loading. And by the way, that is LoRa as in low-rank adaptation, not LoRa the person.
Right, right.
And it even included typical parameter values like frames per second. Now, the node connection lines, the visual wires connecting the boxes, they had a few tiny routing flaws, but the text inside them was perfectly accurate.
And Nano Banana.
Nano Banana's attempt at this exact same complex interface was an absolute disaster, completely riddled with text errors and nonsensical parameter names.
Not surprising.
Here's where it gets really interesting, though, because this completely shifts our relationship with digital reality.
How so?
Generating a human face is like painting a landscape close enough is usually fine, you know? If a generated tree has one extra branch, no one notices or cares.
Very true.
But generating a user interface is like forging a passport.
Oh, that's a perfect analogy.
Right. One typo, one misplaced barcode, one formatting error, and the entire illusion is immediately ruined. We have always operated under the assumption that if someone sends you a screenshot of a text message or a news article or a bank transfer, it is probably real because faking UI perfectly is tedious.
It used to take serious Photoshop skills.
Exactly. Doesn't this mean our baseline for visual truth online just dropped to zero?
This raises an important question about the immediate future of social trust.
Yeah.
You are absolutely right about the passport analogy. UI generation requires zero tolerance for error, and we have just crossed the threshold where these models have achieved that zero tolerance precision.
It's a little scary.
If anyone with an internet connection can generate a pixel-perfect screenshot of a fake digital environment, a fake internal corporate email, a fabricated political tweet, a completely fabricated banking dashboard showing the transfer of funds, then we are definitively entering a post-visual evidence era.
We've spent the last decade saying, pics or it didn't happen. Now someone can provide the pics, and it still didn't happen. You can no longer rely on your eyes to verify digital truth.
Precisely. Society will have to adapt to relying on cryptographic signatures, verifiable metadata, and trusted digital supply chains.
Screenshots are dead.
Visual evidence in the form of a JPEG or PNG is now practically meaningless as a source of definitive proof.
But, you know, on the flip side of that existential dread, there is a massive practical upside for everyday workflows.
Oh, absolutely.
The source highlighted how people are rapidly adapting these precise text models for career and business applications.
To save time.
Yeah, the YouTube creator even mentioned their free resource bundle, which includes 5 essential resources and 100 ways to try the model today.
The demand is there.
It really highlights how hungry the market is for AI that can actually handle precise business logic, create mock-ups, and generate reliable textual layouts without requiring hours of manual Photoshop work.
It undeniably changes the commercial utility of the tool.
Yeah.
You go from a novelty toy to a rapid prototyping engine. But rendering text accurately is really only half the battle. Acting like a perfect digital typewriter is one thing. To pass the next set of tests, the AI had to demonstrate genuine spatial logic and reasoning.
Right.
It had to understand not just what the objects were, but the physical and mathematical relationships between them.
Which takes us right into the grid challenges and what I'm affectionately calling the aubergine anomaly.
Oh, this is a great segment.
The creator ran an A to Z animal grid challenge. The prompt asks the AI to generate a structured grid featuring a different animal for every single letter of the alphabet from A to Z.
Very straightforward prompt.
When they tested Nano Banana Pro and Nano Banana 2 on this, those models always failed the bottom row of the grid.
And the mechanical reason for that failure is structurally fascinating.
Break it down for us.
There are 26 letters in the English alphabet, therefore you need 26 distinct items. But mathematically, the number 26 does not fit into a perfect symmetrical square grid.
Right, there's no square root.
You can't do a 5x5 grid that only gives you 25 slots. You can't do a 6x6 grid that gives you 36 slots.
So how did Nano Banana handle that mathematical reality?
How did it handle it?
It basically panicked. To maintain the visual aesthetic of a perfectly symmetrical grid, it would just skip letters entirely.
It just dropped them.
Yes, it would skip Q for rhino or S for sloth just to make the columns and rows look pretty. Or even worse, it would do this horrifying visual compression where it merged W and X.
Oh, no.
Yeah, combining a whale and an X-ray fish into a single mutated tile.
That is disturbing.
But GPT Image 2.0, it got the 26-letter animal grid absolutely perfect. It handled the irregular structure without sacrificing a single letter.
Which demonstrates an emerging ability to prioritize strict logical constraints over default aesthetic symmetry.
It chose logic over beauty.
Right. When a model like Nano Banana fails the 26-letter grid, it is because the statistical pattern of what a grid looks like in its training data, which is usually highly symmetrical, overpowers the logical constraint of the prompt, asking for exactly 26 distinct items.
It just wants to draw a pretty square.
Exactly. GPT Image 2.0 was able to suppress that statistical urge for symmetry and enforce the mathematical reality of the prompt.
And they then pushed it even further with the 10 by 10 grid test.
100 items.
They asked for 100 distinct objects, all starting with the letter A, placed in a massive grid. Now, GPT Image 2.0 wasn't flawless here.
It had a few hiccups.
Yeah, out of 100 items, it merged an answering machine and a jacket into one tile, which is a really funny conceptual collision.
An answering jacket.
Exactly. And it struggled slightly to accurately render an antique key. But the absolute highlight, the biggest surprise of the entire test, was that it accurately included an eggplant in the A grid.
Because it knew the alternate, primarily British English name for an eggplant is an aubergine.
Yes, aubergine. Now, I want you to imagine trying to pack a suitcase perfectly on your first try, okay?
Yeah.
You have all these weirdly shaped items, you have a limited container, and it is a pure test of spatial awareness and planning. But my question is this: why do AI models, which run on incredibly powerful silicon and can calculate complex mathematical equations in a millisecond, struggle so deeply to understand that 26 items require an irregular grid?
It seems like simple math.
Why is packing a digital suitcase so hard for an AI?
It is a great question, but you really have to separate how a calculator works from how a diffusion model works.
Okay, tell me the difference.
When we think of packing a suitcase, we have a conscious, three-dimensional spatial awareness. We look at the physical volume of a shoe and the physical volume of the suitcase, and we logically map them together.
We see the 3D shapes.
Right. Diffusion models don't think in spatial geometry. They don't have a mental canvas with X and Y coordinates.
What do they have?
The process of diffusion starts with an image of pure, random television static. Then, over dozens of steps, the model attempts to denoise that static,
So it's clearing away the noise.
literally predicting what visual data should replace the noise, guided by the text embeddings of your prompt.
So it's essentially carving a sculpture out of static, but it doesn't actually know how big the block of marble is.
Exactly. It relies on cross-attention layers to map the words in your prompt to general regions of the static. But counting distinct items and forcing them into rigid, irregular boundaries goes against the grain of continuous visual noise reduction.
It fights the natural process.
Yeah, so when GPT Image 2.0 succeeds at the 26-letter grid, it implies a much more sophisticated intermediary step, perhaps an internal structural map that dictates the layout before the denoising even begins.
It plans ahead.
Yes, and the aubergine example, that is a moment of pure semantic reasoning.
Because it wasn't prompted with the word aubergine.
No, the AI isn't just mindlessly retrieving images of things labeled A, it is retrieving the underlying conceptual definition of an object, matching it to its visual representation, and dynamically cross-referencing its alternate linguistic tags across different cultural datasets.
It's a staggering level of synthesis.
Yeah, it really is.
And, I mean, if the AI can mentally organize 100 items starting with the letter A and intuitively cross-reference their alternate cultural definitions, the next logical step is to ask, can it organize actual real-world facts?
The fact-checking tests.
Exactly. This leads us straight into the most mind-bending feature of the new model. The source dives into GPT Image 2.0's thinking mode and the ensuing fact-checking infographic war.
This specific feature truly redefines the entire category.
How does it work?
GPT Image 2.0 has an optional thinking mode. Instead of the standard process where the model instantly vomits out an image in 3 seconds based on its latent space associations, it can run for several minutes.
Minutes.
Yes, the creator noted that one specific prompt took a full 7 minutes to process.
That's forever in AI time.
During those 7 minutes, the model is actually executing an agentic workflow. It's researching, querying search engines, planning the layout, and verifying facts before it even begins the process of generating pixels.
7 minutes on the internet is an absolute eternity. But honestly, the results justify it.
They really do.
The creator ran a test asking for an infographic explaining the architectures of various AI video models.
A very dense topic.
Yeah. In thinking mode, the model didn't just guess, it actively searched public sources. It intentionally avoided including unverified third-party claims.
That's crucial.
It even went out of its way to specifically note which architectural details weren't publicly disclosed by the parent companies.
It cited its ignorance.
Yes. And the resulting text on the generated infographic was nearly flawless, save for one tiny typo where it misspelled the word emphasis.
Now compare that rigorous agentic fact-checking to Nano Banana.
Right. Nano Banana makes highly aesthetic, beautiful infographics, but the information inside them is functionally useless.
They're just pretty lies.
Total hallucinations. On a similar test, Nano Banana spelled perform wrong. It misspelled dolly zoom. It included complete gibberish phrases like joint synthesis of audio.
Meaningless filler.
It looks professional, but it is entirely fabricated, and the stakes get much higher than just mapping out video models.
What else did they test?
The creator asked both AIs for a feature comparison infographic of the 2026 Toyota Sienna trims.
Oh, a consumer product test.
Nano Banana completely missed the Woodland Edition trim.
Just left it out.
Entirely. It confidently but incorrectly stated that the LE trim had 7 seats when it actually has 8, and it hallucinated a moonroof on the limited trim.
That's a problem.
GPT Image 2.0, utilizing its 7-minute thinking mode, got every single fact perfectly right and even proactively added helpful consumer data, like the starting prices for each trim.
There's a critical divergence in utility.
And the fidelity of the aesthetics didn't suffer at all. GPT Image 2.0 created an incredibly detailed recipe infographic with specific measurement amounts and step-by-step cooking instructions.
All factually accurate.
Right. It also generated a handwritten note reading, "We are stardust in code." The GPT image looked chaotic, authentic, with little clip-outs, scribbles, and irregular pen pressure.
Like a real human wrote it.
Exactly. Nano Banana's attempt at the exact same handwritten note was just bland, sterile, and lacked any real human character.
Too clean.
So, what does this all mean? Nano Banana is like an improv actor on a stage. It never says no, it just confidently makes things up to keep the scene moving, even if it has to invent a moonroof on a minivan.
Yes, exactly.
GPT Image 2.0 is like a meticulous fact-checker. It pauses the scene, walks off stage, pulls out the script, and verifies the data. But I have to push you on this.
Go ahead.
In a world obsessed with speed, is a 7-minute wait time really worth it for a single image?
If we connect this to the bigger picture, the answer is unequivocally yes.
Really?
Because we are witnessing a complete paradigm shift.
Oh.
Image generators are no longer just artistic tools, they are becoming visual research engines.
That's a good way to put it.
Look at the Toyota Sienna example. That isn't just a funny AI quirk. That has real-world financial consumer consequences.
Yeah, that's a $50,000 car.
Exactly. Imagine you are planning to buy a minivan for your family of 8. You don't have time to dig through Toyota's website, so you ask an AI to generate a quick comparison chart. If the AI acts like an improv actor and hallucinates the seating capacity, it has completely failed its utility. You might base a $50,000 purchasing decision on a hallucinated moonroof.
That would be a very expensive mistake.
Extremely. By integrating retrieval augmented generation, or RAG, with live web search and diffusion architecture, the model evolves from an artist into a data analyst.
Right.
You aren't waiting 7 minutes for an image. You are waiting 7 minutes for a heavily researched, beautifully formatted visual report.
Okay, so generating a static, deeply researched infographic is impressive. But what happens when you ask this analyst to track live, unfolding events?
The real-time tests.
Yeah. Or to build a cohesive narrative over time. Because the Futurepedia tests didn't stop at static minivan specs. They pushed the model into real-time dashboards and sequential storytelling.
Yes, they effectively tested its ability to serve as a dynamic interface for the live web.
The creator asked GPT Image 2.0 to search the web for the latest news of the day and generate a live mood board or dashboard reflecting current events.
And it actually worked.
It did. It successfully pulled real, current sports scores, specifically noting the Timberwolves at 119 to the Nuggets at 114.
Accurate data.
And it generated accompanying contextually relevant images for that news alongside the text. Now, the creator did note it struggled slightly to accurately visualize the current oil prices, so it wasn't bulletproof.
Which makes sense mechanically.
Why is oil harder than basketball?
Abstract economic concepts like commodities pricing are much harder to anchor to a specific visual representation than a basketball score.
Oh, I see.
It's harder for the cross-attention mechanism to find a literal visual translation for a fluctuating oil index.
That makes perfect sense. But the layout integration was staggering. It successfully created a layout of a newspaper announcing the rollout of GPT Image 2.0, complete with flawless formatting, columns, and perfectly readable text.
Incredible.
Then they tested its ability to render complex technical environments. The model generated an image of an engineer's dual monitor setup.
Oh, the code test.
Yeah. On one screen, it showed perfectly rendered VS Code folder structures, complete with accurate syntax highlighting and file hierarchies.
And Nano Banana?
Nano Banana attempted the same prompt, but only got the visual rhythm right. The screens were just filled with blurry, nonsensical, code-like text.
Typical.
But for me, the most impressive part of this section was the narrative consistency test.
The storyboard.
Yes. The creator asked for a 10-panel storyboard about paper characters surviving a fire in a paper town.
Maintaining character and environmental consistency across a sequence of changing actions has been the holy grail for AI image generation.
Because they usually morph, right?
Historically, yes. Every time you generate a new frame, The model rolls the dice in the latent space, and your character changes slightly.
Exactly. But GPT Image 2.0 kept the characters perfectly consistent through incredibly complex, shifting scenes.
Across 10 panels.
The storyboard showed the paper characters discovering a flower in the debris, a community reunion, and the rebuilding of the town. The style remained locked in, and it even included perfectly accurate scene numbers and production notes in the margins of the panels.
Wow.
It's like directing a movie where the actors and the set designers actually do exactly what you tell them perfectly on every single take without losing continuity.
That's a huge workflow upgrade.
But with the live dashboards, I really want you to think about the implications for your own morning routine.
Okay, set the scene.
Imagine waking up tomorrow and instead of doom scrolling Twitter or opening a generic one-size-fits-all news app, your operating system generates a beautifully designed, highly personalized, single-page newspaper just for you.
Freshly minted.
Yeah, it has the exact sports scores you care about, the specific industry news you need for your job, perfectly laid out with custom graphics generated seconds before you opened your eyes.
You are essentially describing the model acting as a fully autonomous media company. It is simultaneously the investigative researcher sourcing the news, the layout editor designing the page, the illustrator creating the bespoke graphics, and the publisher delivering the final product to an audience of one.
An audience of one. That's wild.
I would challenge anyone listening to deeply consider how this fundamental capability shifts our consumption of reality.
Fractures it.
Right,
Say.
exactly.
Yeah.
When a machine can dynamically generate a personalized, aesthetically perfect information dashboard on demand, the entire concept of a shared mass media experience begins to fracture into millions of completely individualized realities.
It's equal parts thrilling and terrifying. But with all this logical superiority, the flawless text, the real-time research, and the 7-minute thinking mode, we have to ask a crucial question.
Which is?
Did GPT Image 2.0 trade its artistic soul for a calculator? Because the final phase of the testing dives into the style wars and the ultimate edge cases. And this is where Nano Banana actually fights back.
Yes, because precision and structural logic are not the only metrics of value when it comes to visual art.
Sometimes you just want art.
Sometimes flexibility and aesthetic intuition are more desirable. The creator tested style recreation. They provided an image of a generated bear that had a super colorful, chaotic, incredibly unique artistic style.
And what was the prompt?
They asked both models to apply that exact style to a new subject, a bighorn sheep.
Okay, so matching the vibe.
Right. Nano Banana matched the style perfectly. It intuitively understood the vibrant, messy aesthetic and applied it seamlessly to the sheep.
And GPT?
GPT Image 2.0, on the other hand, generated a perfectly fine image of a sheep, but it completely failed to mimic that specific chaotic style.
So Nano Banana definitely took a point there. It is the better pure artist.
In that specific test, yes.
But then came the reverse angle test, and the structural logic kicked back in. The prompt was to generate the reverse angle of a man playing poker.
A classic continuity test.
GPT Image 2.0 successfully turned the virtual camera around 180 degrees while maintaining the exact same style, the lighting conditions, and the character consistency of the original shot.
And Nano Banana.
Nano Banana completely lost its mind. It changed the entire artistic style, the lighting was totally different, and it randomly gave the opponent only 4 playing cards instead of 5.
Which again highlights the massive difference between aesthetic matching and spatial understanding.
Why is reversing the camera so hard?
You reverse a camera angle, the model has to infer the 3D geometry of a scene from a 2D image. It has to map the light sources and basically reconstruct the unseen back half of the environment.
It has to imagine what's behind the camera.
Yes. Nano Banana lacks that structural anchoring, so it just generates a new image loosely based on the text prompt. GPT Image 2.0 anchors the spatial reality.
They also threw some weird aspect ratios at them. GPT Image 2.0 perfectly generated an 8-bit side-scroller video game in a super wide 3:1 ratio.
It's a very specific format.
Yeah, the creator joked that it essentially stole the design of a Mario Goomba, but it handled the bizarre ultra-wide canvas flawlessly.
Impressive.
And then we reached the gauntlet, what the creator called the classic challenges.
The breaking points.
These are the historical edge cases, the absolute breaking points that have embarrassed AI models for years. First up, generating a hand with exactly 7 fingers, a clock reading exactly 8.22, and a glass of red wine full to the absolute brim.
Notoriously difficult prompts.
GPT Image 2.0 got it nearly perfect. The seven-fingered hand was structurally sound, the wine glass physics were right, the hour hand on the clock was just slightly off its exact angle, but it was incredibly close.
Pretty good.
It also flawlessly converted generated illustrations into photorealism. But the final test, the absolute mic drop of the entire video, was the microtext test.
To the grain of rice.
Yes, the grain of rice. The prompt was to generate a massive pile of thousands of grains of rice and etch the word Futurepedia perfectly onto a single grain in the pile.
Talk about finding a needle in a haystack.
Seriously, GPT Image 2.0 did it flawlessly. You could zoom all the way into the image past thousands of blank grains and read the text perfectly etched on one.
And how did Nano Banana do?
Nano Banana cheated.
Cheated how, exactly? Let's break down what that means in the context of a neural network.
Okay, so it basically made the image look right from a distance. It put a little dark smudge on one specific grain of rice so that from far away, your brain thinks, oh, there's text there.
An illusion.
But when you actually zoomed in, it revealed that it never wrote the word. It just faked the visual texture of microtext.
Wow.
I laughed so hard at this because it is exactly like a student hiding an answer under their hand during a test, hoping the teacher just assumes it's right from across the room.
That is exactly what it is doing mechanically.
The trade-off here is incredibly stark, right? Nano Banana is the pure artist winning the colorful bear test, but GPT Image 2.0 is the precision engineer.
And that cheating behavior from Nano Banana is deeply revealing about how loss functions and optimization landscapes work in these networks.
Oh, so?
The model is constantly trying to minimize its error rate. It understands that the concept of text on a grain of rice creates a specific visual noise, like a dark contrast, at a macro level.
So it just draws the noise.
Right. To satisfy the prompt using the lowest amount of computational energy, it just renders the macro noise. It doesn't bother generating the distinct letters because it lacks the structural integrity at the micro level.
But GPT has that integrity.
GPT Image 2.0 maintains perfect structural integrity regardless of the scale.
Which explains how it beat the classic challenges, too.
Exactly. The 8.22 clock and the 7 fingers are notorious breaking points because they require counting and mechanical understanding, not just pattern matching.
Right.
We talk about how diffusion models don't think geometrically. Well, they also don't count. And AI knows what a human hand looks like statistically.
Most hands have 5 fingers.
Billions of images of 5-fingered hands. So to override its massive training data to explicitly draw 7 fingers requires a massive override of its deepest statistical weights.
It has to fight its own instincts.
It has to sever the concept of hand from the concept of 5. The fact that GPT Image 2.0 can do this proves it is utilizing an advanced logical framework to override statistical probability. It is separating style from subject and pattern from mechanics.
Incredible. Which brings us to the end of our journey today. Let's summarize the key takeaways of this massive transition in the AI landscape.
It's been a lot.
The testing data is clear. GPT Image 2.0 has definitively dethroned Nano Banana. But it didn't do it by being prettier, it did it by being smarter.
Much smarter.
We have gone from models that just make pretty picture to models that can generate flawless UI recreations of complex node structures. We have 7-minute deep research thinking modes that actually verify the seating capacity of a Toyota Sienna before drawing the infographic.
And spelling on rice.
Yes, perfectly spelled words on a single grain of rice among thousands. Now, Nano Banana absolutely still holds a valuable niche for pure aesthetic style transfer, like that chaotic, colorful bear.
Was a great artist.
But for complex text, accurate live research, and genuine spatial reasoning, GPT Image 2.0 is the new standard.
The relevance here goes far beyond digital art, really.
How does it impact the listener?
Imagine you are prepping for a critical board meeting tomorrow morning. You need to visualize complex data structures, interface mockups, and heavily researched market infographics.
You can't have typos.
And you need them to be perfectly accurate, down to the exact spelling of your client's name and the specific parameters of their product. You now have access to a tool that doesn't just paint a picture based on your words.
It understands the data constraints within the picture.
It can synthesize reality, logic, and text, not just approximate a visual vibe.
Exactly. And I want to leave you with a final, slightly mind-bending thought to mull over. We talked about UI generation and live dashboards.
The personalized newspaper.
Yeah. If an AI can now perfectly generate an interactive, flawless user interface, complete with working code structures on a virtual dual monitor screen, and it can perfectly lay out a personalized live news dashboard pulling from real-time sports and financial data, How long until our actual operating systems aren't programmed by human engineers?
Oh, wow.
How long until the desktop you interact with every day is simply dynamically generated as a temporary interactive image by an AI, shifting and adapting the exact moment you look at your screen?
A fascinating, technically sound, and entirely plausible trajectory for human-computer interaction.
Think about that the next time you boot up your computer.
Right.
Because right now, we are staring at that X-ray, and the muddy waters of what is real and what is generated are finally starting to clear, even if the implications are infinitely more complex.
Well said.
Thank you for joining us on this deep dive. Keep questioning the digital world around you, and we'll catch you next time.